Hello everyone. So welcome to the channel of DigiiMento. Today we are going to discuss DBMS, okay? And this subject is very easy scoring and comes for 8 to 10 marks. Not 8 to 10, just 8 marks you can think of, okay? So this is one of the easiest subject and scoring subjects. So let's revise this today completely. All right. So I am live, okay? It's confirmed. Now let's get started, everyone. So I want to tell you that I have already completed C programming, algorithm, data structure, okay? And I am taking subjects in such a way that they are very easy scoring, okay? So you will say that why not COA, CN? They are a little bit tough and scoring as well and rank deciders for gate, but still I am taking the subject first which are easy and very good for scoring. So DBMS is that kind of subject. Now let's get started, everyone. So let's revise DBMS quickly. The very first is blocking factor. So blocking factor, which is BF, is average number of records by block. Okay? So it's like BF, blocking factor, is equals to block size by record size, where block size is greater than record size. Okay? Now let's see spanned organization, okay? Span organization and unspan organization. Span organization and unspan organization. So very first is a record can be stored in more than one block. Okay? And here is record can be stored in a particular block. Second is blocking factor is equals to block size by record size, and here BF is equals to block size by record size. Block size by record size. Okay? Third is no memory wastage but block access cost increased. Third is block excess cost, reduce, but wastage of memory. Alright, wastage of memory. And the fourth one is suitable for variable length record and this is suitable for fixed length records. Okay. This is the case. And default is unspanned organization, and blocking factor for max possible record is by block. Okay. So that is the case, everyone. Now let's see ordered file and unordered file. Ordered file and unordered file. Searching is easy. In unordered, insertion is easy. Second is, here insertion is expensive and here searching is expensive. Okay. Third is to access any number of block its ceiling of log to be, and in unordered search the average case is b/2 and worst case is b. Okay. Like this. And few point you should note that one index record size is equals to size of search keys not equals to size of pointer. Okay. And number of data blocks is equals to number of records divided by blocking factor of database file. Okay, everyone. Anyone having any doubt in this? Any doubts till now? Please see this. Any query, any doubt? Okay, so let's see the next one now. Dense index and sparse index. Okay. Dense index, sparse index. So dense index entry created for every search key value. Okay, and here it is, index entry created for every some search key values. It's not every, for some search key values. Okay, not every, for some. Okay, here is number of index entries is equals to number of database records, and here is number of index entries is equals to number of blocks, is equals to number of block. So blocking factor of index size is block size by index record size. Like this. Okay everyone, now let's talk about single level ordered index, where we have primary index, clustering index, secondary index. Okay, so first is primary. Primary index so primary index here is key plus ordered file. Clustering index is non-key plus ordered file, and secondary index is key, non-key plus unordered file. Okay, so at most one primary index, secondary index, okay, and greater than one secondary index possible. So in relation, either clustering index or primary index, but not both. Okay, and excess cost will be multi-level index, okay, with k plus 1 blocks. So to access a record using index, so average number of blocks is ceiling log 2 log base 2 blocks. So I will write this 2 points, okay? To access a record using index average number of blocks access is equals to log log 2 base blocks, okay? And n level is multi-level index where number of blocks access to search a record equals to n plus 1 equals to n plus 1. Now let's get with the B tree concept, okay? I hope this is absolutely clear. The storing concept is absolutely clear. Now let's see B tree concept. So B tree, so this P is block, okay, child or index pointer. This PR is record or data pointer. This K is search key. And this is order, okay, where max possible child pointer that can be stored in node, okay? So every internal node except root, I am writing every internal node except root. So block pointer is equals to P by 2 and this is minimum, okay? And minimum keys P by 2 minus 1, okay? And block pointer is P and this is for the max, okay? Max keys P minus 1. So root can contain, okay, root can contain minimum 1 key. Root can contain minimum 1 key. Remember this, and each level node should be same level. Each level node should be same level. And here order P by okay, so order P, which is P into block pointer plus P minus 1 key plus RP, okay, by block size. All right. So this is the case. So note down this, everyone. And now here order P minimum, order P maximum, order P maximum. So high by level, min node, max node, minimum, block pointer, min number of keys. Okay, high level, max node, max number of block pointer, and max keys. H by H plus 1, P minus 2, H minus 1. Here P by 2, H, and here 2, P by 2, H minus 1 into P by 2 minus 1. So H plus 1, PH, P H plus 1, and PH P minus 1. Okay, everyone. Now let's talk about B plus trees. Okay, B plus trees. All keys are available at leaf node. Okay. Second is internal node is equals to number of child pointer. So leaf node contains key and record pointer plus 1 block pointer. Okay. So order of internal node is equals to P into BP plus P minus 1 key smaller than block size. Okay, an order of leaf node P minus 1 keys plus record pointer plus 1 BP block size. Okay, so we have to split of internal node is same as in B tree, but the split of leaf is different from B plus tree. So B plus tree best suited for sequence access for range of records. When there is a range of record, then B plus tree is good. Okay, now let's talk about procedural query language, which is relational algebra. Okay, and after that non-procedural SQL languages, SQL. After that are TRC and DRC. So let's talk about relational algebra now. Very first. So relational algebra, query executed on database, tuple by tuple, one tuple at a time. Okay. So derived operation and basic operations are there. In basic operation, we have selection, projection, cross product, union, set difference, rename. And derived operation means join and their types, division, intersection. Okay, and to apply set operation, which is union, difference. So like this it is, right everyone? So let's see now cross product in this. It is like this, it is denoted like this, okay? R into S, which is N1 into N2 tuples, and attributes will be C1 plus C2 attribute. So for cross product, relation not required to be union compatible, okay? What is cross join? Cross product, natural join. That means anyone should have two tuples similar. Okay, sorry, two attributes should be similar of both of the table, then only natural join will work. Otherwise, natural join will act as cross product. Okay, or everyone? Then inner join we have conditional join, equi join, natural join. Outer join we have left outer join, right outer join, full outer join. Okay, and this all joined information and how they are applied, that you should know. Okay everyone, that you should know. After that, let's talk about structured query language. DDL. DDL, it's create, update, alter, drop table. Second is DML, which inserts, update. Okay. After that, DCL, it commit, it abort. Fourth is DQL, where is from, where, something like that. And one thing you should know, that SQL is not case sensitive. And mandatory SQL clauses are what? Select and from. And SQL works as multi-set and returns duplicate. So in SQL, duplicate is allowed till the time you are not using distinct keyword. Okay. So if you feel that whatever I am writing is important, do write it. If you feel that whatever I am saying, I am in the class, speaking in the class is important, but it is not written in the board, so do note that as well. Okay. Or just by hearing, if you are remembering the concept, that is also okay. If you feel like, okay, so these are the points are there in my notes, I'm here to revise and I can hear that and can revise it like that without noting it, so that is also okay. Okay. Now SQL clauses, we have select, from, where, group by, having, order by. What is aggregate functions? Count, sum, average, max, min. And aggregate functions cannot be lowercase. Okay. So null in the SQL means what? Not existed or some unknown value. So arithmetic operation with null will always give you null. Arithmetic function, sorry, aggressive function will ignore null. Count will ignore null. Sum will ignore null. Average will ignore null. Max, min will ignore null. And comparison with null will always give value unknown. This you should know. These are the points you should know. After that, set operations, union and union, all you should know how to do it. Intersection, intersection, all you know. Minus and minus, all you should know. Minus is nothing but except, I am writing here the keyword minus. Minus and minus all. Minus is nothing but except, and minus all is nothing but except all. Okay. So when aggregate operator and other attributes is used to select clause is allowed only if the attribute will be in group by clause. So aggregate function will work where? when the select clause is allowed only if it is in group by clause. Okay. After that, let's talk about entity set. Okay, everyone. So what is entity set? Collection of similar entities that share the same properties. Okay. What is relationship set or relationship? Association among several entities. Okay. Attributes, which is proceed to derived on entities. What are attributes? Let's say this is a relation. A, B, C, D are the columns, and these columns are nothing but attributes. Okay. And what are the types of attributes, everyone? Simple and composite, single multi-valued, stored and derived, key, complex and descriptive. So you should know about attributes as well. After that, let's see mapping cardinality constraint. First is 1-to-1. So 1-to-1 is like this. This is 1-to-1. 1-to-many. One-to-many is like this. Third is many-to-one. It's like this. Fourth is many-to-many. So this is 1-to-1, okay? Many-to-many is like this. Okay? Now referencing relation is table with foreign keys, and foreign key table is a child table. Referenced relation is table referenced by foreign key, which is parent table. And deletion from referenced relation can increase into referencing relation, may violate foreign key. See, if you will delete anything from parent key, there will be referential integrity constraint. Okay? That you should know. And foreign key may contain duplicate or null values. Alright? Yes. Now, ER2 DBMS table. How many tables from this relation we can make? So, if the table is 1-to-1, so how many tables required? 2 tables required. If the relation is 1-to-many, so 2 tables again is required. If it is many-to-many, so 3 tables is required. And if it is 1-to-many, then 2 tables required. Okay? And partial participation at both sides with about mapping are same as above. Okay? So partial participation is like this. Total participation is like this. So if total participation at both the side is there, okay, and that is the relation in 1:m, m is to 1, and 1:1, and m is to 1, then only one table required. But at both the side, total participation should be there. Okay? So total participation at one side. Okay? Total participation are there only at one side now. So, see, total participation I am writing TP is there at the one side where the relation is 1:m, many is to 1, 1:1. Okay, so here at one side, total participation at one side. So here only one table required. and here total participation at any site, okay, in many to many, then here 2 tables required. 2 tables required. Till now, any doubt everyone having? Okay, so let's see the next one now. Acid properties, you all know that the meaning you should know of acid property. First is atomicity, consistency, isolation and durability. All this you should know, everyone. Okay, then what is a schedule? Sequence of instruction that specify the chronological order in which instructions at current transactions are executed. And what is serial schedule? Execution of one by one. And non-serial schedule is interlinked execution of 2 or many transactions. So for n transactions, n factorial serial schedule possible. Okay. So can you tell about conflicting schedule? So if RW is there, it's a conflicting schedule. WR is there, it's a conflicting schedule. And WW is there, so it is a conflicting schedule. And non-conflicting schedule, R is referring to R or R is referring to W, but the items in them are completely different, then they are non-conflicting. Okay. So to know that whether the schedule is conflicting schedule, so we have to make the precedence graph for it. So a schedule is serializable if there is conflict, view serializable, able or both. Okay, and if a schedule is conflict serializable, then it is already view serializable, but vice versa is not true. So it is if a schedule is conflict serializable, then it's already view serializable, but vice versa not true. Not true. Okay, everyone. Okay, so sorry everyone, suddenly what happened, the screen got blanked and I wasn't able to deliver anything. Okay, so let's get ahead now. Let's see view serializability. So if in schedule S1, I1 reads initial value of Q and then S also, so T1 must read the initial value of Q. And if there are certain rules for view serializability to check, so that you can do. Okay, first you should know how to see view serializability and view equivalence. Okay, and conflict serializability and conflict equivalence, these four topics should be absolutely clear and very good strong from your side. Okay, so what are the problems due to concurrent execution? Read write problem, uncommitted read, dirty read, unrepeatable read problem, lost update problem, phantom tuple problem. Okay, so these are all the things. And so non serializable schedules is equals to non serializable schedule is equals to total concurrent schedule minus serial schedule, which is of n factorial, and this m is nothing but number of transactions. Okay, and you should be clear of recoverable schedule. Okay, all of these things. Okay everyone, so please note down this. Now we will discuss about types of lock. So there is shared lock. Shared lock means only you can read. Exclusive lock means you can read, write, and you can read, write both. So two-phase locking means in two-phase locking there are growing phase. Growing phase means occurring lock. Shrinking phase means releasing of lock. And lock point means position at which lock operation or unlock operation happens. Now let's write some points about 2PL, strict 2PL, rigorous 2PL, and conservative 2PL. Okay, so let's see that. So on such topics also questions can be asked. So 2PL, let's see. Any doubt till now? Any doubt till 2PL? Okay, so let's see the points of 2PL. First is ensures conflict serializability. Second is serializability order determined by lock point. Third is 2PL not assure, not ensure recoverability. Okay. Fourth is 2PL suffers from deadlock. So this is may suffer or may not suffer. It's like this. Fifth is 2PL suffers from starvation. It is like this. Okay, now let's see strict 2PL. Strict 2PL. So 2PL plus all exclusive logs, okay, taken by the transactions must be held until commit or rollback. Alright, and it ensures conflict, serializable, recoverable, schedule, cascade less, and strict recoverable. And but suffers from deadlock and starvation. Okay. So this is the point, everyone. Now let's see regress 2PL. The first one is 2PL plus all logs shared and exclusive must be held by transactions, okay, until commit or rollback. Until commit or rollback. Okay. And second is suffers from deadlock and starvation. And what is conservative 2PL? So conservative 2PL so here each transaction acquire all the logs in the beginning of execution and release after commit. Okay, and this ensures conflict serializability, recoverability, cascadeless, strict schedule, no deadlock. Okay, no deadlock, but suffers from starvation. Okay, but suffers from starvation. After that, please look into timestamp protocol. Okay, timestamp protocol is free from deadlock, but not recoverable and starvation happens. Okay, Thomas Wright rule also, see how to solve the problems on that, very very important. Okay, after that see for the properties of trivial, okay, functional dependencies property, reflexive, augmentation, transactive, decomposition, union, like this. After that see how to solve super key, okay, how to calculate super key, candidate key, prime attributes, that you can see. Okay, so just writing the definition is not sufficient, how you should know how to solve it. After that you should see the equality between two FD sets, that whether two FD sets are important or not, and I'm discussing this because directly 1 mark question comes from here. After that you should also know how to find minimal cover, okay, and maximum number of candidate key, how to find. Okay everyone, after that you should also know what is lossless decomposition, lossy decomposition, and after that dependency preserving. Okay, then normal forms you should know, first normal form, second normal form, third normal form, BCNF. So every normal form contains lower normal form. So first is first NF, second NF, 3 NF, BCNF. So you should know about first NF, you should know about what is partial dependency, second NF, third NF, NF and BCNF. Okay. So I will write here the properties. So first NF means relation does not contain any multi-valued attribute, and by default DBMS is always in 1NF. 2NF means partial dependencies should not be there. First of all, it should be in 1NF. After that, no partial dependencies. And please study about what is partial dependency, everyone. Okay, and here proper subset of candidate key should not derive non-key attribute. So prime attribute, non-prime attribute also please know. And if we talk about 3NF, so x deriving y, so either is x is super key or any key, or this y should be prime attribute. This y should be prime attribute. And now if you talk about BCNF, so BCNF x deriving y, so this x should be any key. You don't have to see about y. Okay, and two attributes are always in BCNF. Two attributes are always in BCNF. Okay everyone. So lossless join is in 1NF, 2NF, 3NF, BCNF. Redundancy problem is not there in 1NF, 2NF, 3NF, but it's there in BCNF because it suffers from multi-valued attributes. And dependency preserving is there in first NF, second NF, third NF, and in BCNF dependency preserving may or may not be there. Okay everyone, so with this we have completed with DBMS. If you have any doubt, please ask me in the comment box. And see, the live will not get stopped, so I will discontinue the live from my side, so it is not just get over from the system. So that's why it may look for 4 hours live, 5 hours live, but it is not. Every live, whichever live I'm taking, it's just of 1 hour. Okay, and I've taken the revision courses on other subjects also. Do check the channel and please revise properly. I have taken all the important things and I've revised that way. So I hope there is no doubt from my side, and do let me know how was the class in comment section. If you are getting benefited, then please